Hey guys, and welcome back to the YouTube video. In this video, I am going to be programming a neural network from scratch that can classify COVID-19 images, and it will tell whether like the patient is COVID-19 affected, is he infected, or is he does he have like pneumonia. So I have three folders over here called COVID, normal, and viral pneumonia. It's a part of the COVID-19 dataset. If you want to download the COVID-19 dataset for yourself, go to kaggle.com and download the dataset. You should have this download link. I will probably leave a little link to this in the description, but remind me if I do. So normally, the neural networks that I've created till now on this channel are all that are either Keras datasets or TensorFlow datasets. So all of the neural networks that I've created till now did not require any loading in, like not specifically, we just did it in 2 lines. But on the other hand, the data that we are using currently is the COVID-19 dataset, and that dataset is not a part of the TensorFlow dataset. It's a one that we need to manually download and use. So it becomes a little bit difficult for us to do it. I'd actually gone ahead and made a neural network similar to this. I'm not going to be making this one. This was just a neural network that I made that will classify like whether I'm happy or sad. But I'm not going to be making that. I figured out I would just make something that you can deploy in the real world and like deploy it to the medical industry. Like this is actually a very useful neural network. Like if you can get yourself 100% accuracy, you can actually deploy this to like the doctors, and you can possibly help them. So obviously you can do this in Google Colab, but I will not do it because if you upload a folder to Google Colab, it mostly needs to be a zip folder. So if you upload a zip folder to Google Colab, then you have to like use the zip library of Python to first unzip it and then load in the data. I don't really like it that way, so I just prefer that I would use PyCharm where I have it downloaded. I will be using Python 3.7, but Python, and this is like the last version which is supported by TensorFlow. You can use 3.9 or 3.8, it won't work. So first, I have just made some imports. I figured out I would just let me just do it again. So I will first import TensorFlow as TF from TensorFlow. I will go ahead and import something like Keras. I'm going to import numpy as np. I will be importing cv2. It stands for OpenCV Python. A lot of the modules we are seeing here need to be installed. So if you just get that squibbly line, just go pip install that module. In case of cv2, you will have to do pip install opencv-python. I will also need from matplotlib.pyplot as PLT. This is a pretty cool trick in Python. Like you can just put a dot and do it, but I don't like to do it, so I just go and do it with Python as PLT. Now we will also need some specific modules like the OS module. These modules are pretty important because they will actually allow me to load in the data. So from tensorflow.keras.preprocessing.image, we need to import image data generator, this one. So this will actually allow me to rescale the images and do all of that rescaling and prepping of the data. I will also need to import one more thing. So from tensorflow.keras.preprocessing, I will import image. So these are the 8 modules we are going to be using. I think we might need one or two in the future, but I think we can do it in this match. So first of all, we will go ahead and just load in the image, the dataset. So what we do is we need to, before that, we need to actually get our image. So, and we need to rescale the image that we get. So what I will do is just about train underscore img. So train image is equal to image data generator, and then I will just about rescale. Rescale is equal to 1 divided by 255.0. Now, you might be saying, we do not have any trained images, then why am I doing this step? The reason being, when we make a dataset out of these images, like currently TensorFlow does not recognize the folder that we are using as a dataset. We need to like tell TensorFlow that the folder that you are looking at right now, it's not just a collection of images, it's like a dataset that we need to use. So for that we need to pass this, first we need to take an image, and then we just need to rescale it, because we cannot directly rescale a dataset. So what we will do is we will take this image, and for every that image in the dataset we will, so this rescaling will be applied. So now what I will do is I will actually get the shape of the image. So for that what I will do is I will just go over here to this, I'll just go to my training data, and I'll just get the COVID one, and I am just going to take this one image. I'm just gonna copy it. I'm just gonna paste it inside of the folder where that is located. Now what I will do is I will just get my image and get the shape of the image. So I'm just gonna go img is equals to image dot load underscore image. So that's the command that you need to do. Don't worry if it throws that little red squiggly line, it will go off. And now we need to just put the path of the image. So that's 0.1.png. Let me have a quick look if its name was that. I think it's a JPEG file. Yeah, it's a JPEG file. So 01.j JP JPG. But we can't just get it in this way. So what we do is we just use cv2 for this. So we do cv2 dot imread, and then we just pass in the name. So we get it over here, we just pass it in that, and we just do that, and then we just pass in the dot shape parameter, and I will just go and print out img. Now, if you are working with a Google Colab, then you won't need to do this step, because Google Colab, if you just do this much, it will just recognize it and print it out. But I'm not working with a Google Colab, I need to perform this little print statement. But this is just to get the shape of the data. This is a pretty important step, because if we just don't know like what the data we are using is, it's going to be very difficult for us to rescale it, build a neural network, and all of that jazz. Alright, so it takes some time for TensorFlow to boot up, especially when you are using all of these pre-processing. I don't know why. Sometimes, and just one side note, if you try and do this with a huge data set, like which has like terabytes of data, uh, you might be needing having a RAM issue, like your computer will crash and it will show you an error called like it exceeds the 10% of the default system memory. You might get that error. So if you get some error like that, uh, you probably will need to rescale the images, make them a bit smaller, or you might need to like have some RAM, or you might need to buy some RAM and put it in your computer, because when that's the downside of machine learning is you need to be having a good amount of RAM in your computer. So you can see this is the shape of the image that we are dealing with. It's 24. Now this is a very good thing. Since this image is three-dimensional, which all the images 99% are, we can actually add another dimension to this image to, instead of making a fully connected neural network, we can go with a convolution and a max pooling approach to increase the accuracy, increase the reliability. So what I will do is I'll just take this, I will copy it, I will just go away and I will make a comment and just paste it over here. So that I can just like have a look at whenever I want to rescale it, I can have a look at it. So what I will do now is I will just type out train underscore dataset is equal to train underscore image. So we take the train image dot flow from directory, so it allows me to have a look at any directory. And then what you need to do is just go over here and you need to go to the COVID-19 dataset wherever that folder is and go to train. You should do not go into any of these folders, just do not do that. Click over and just hit Control C. If you're on Mac, I don't know how it's done. If you're on Linux, I don't know how it's done, but for Windows, this is how it's done. There's this problem, you just need to replace these slashes because it does not take such type of slashes, so just do that everywhere wherever that slash is. We simply need to do this step. Once we do that, we need to now just go ahead and give it some things called a target size. So these are some parameters that you need to give to the image. So it's going to be a 200 target size. Then we need to give it a batch size. So since we are the dataset that we are using currently is not some huge dataset. It's like I would say it's okay, like it's not something too big. So the batch size we are gonna be giving it is not going to be something too high. So I was just going to be giving it a batch size of 50, and I need to give it a class underscore mode of binary. So since we are classifying the images, we need to give it a class mode of binary. Now if the dataset you are using as validation images, all of these steps you just need to make one more time just for val image and that. But since we do not have any validation image, we do not need to do it. And you can see this is so easy, we can easily make this dataset. Now I'm just gonna define the model. So I'm just gonna go model is equal to keras dot sequential, and I can just put this under this. So first of all, I'm not going to be going for a convolution approach. I'm actually giving it as a challenge to you guys. I've actually made a video on the CNN, my last video on this channel, so go check it out and you will get all the information you need to make this convolution neural network. I'm just going to be making a very simple neural network because you can then just add some more layers and just expand on that, because this is just like how you can load in and how you can make a network. Then you can increase however you want. So I'm just gonna go with 250 and a activation of ReLU. You can go with TANH. I mean that's a pretty good activation, but you can also go leaky ReLU. You can use something like there's a bunch of activations. You can use any of them, but I figured out that ReLU was working really nicely, so that's why I just really use that one. This one will just have 100, a little bit less I know than the first one. Again ReLU, you can just experiment with the different activations, which one you want to go with. So I'm just gonna put gas.layers.dense. I think I'm just gonna make this the output layer. Activation of, I'm just going to go softmax. You can go sigmoid softmax. I have tried out with sigmoid also with different other neural networks, and it actually works pretty nicely. So let's actually just run the code right now and see if we are getting any error or not. Or so if everything I've done correctly, then it should tell me the number of training images and how many classes they belong to. You can see found 251 images belonging to 3 classes. If you get that, then the computer has successfully recognized these images as a dataset, and now you can finally compile and fit the model, and you will be able to get the answer. So I'm just going to go model.compile optimizer as RMS prop. So oh yeah, I'm actually changing my optimizer. Yeah, actually, you know what, Adam, I have like Usually I sometimes give RMS prop also because even that's pretty good uh, optimizer. Loss is as sparse categorical cross entropy. I think we need to go binary for this, but we'll see. Metrics as accuracy, and there we go. So metrics is basically like on what the optimizer will improve the thing. So I'm just gonna go modular fit. Over here we need to not pass in the image, we need to directly just pass it the dataset, the epochs. So we're gonna go 3, and I don't think we need anything else. And I think we can just run the code right now and we will have the neural network. Check over there. Now, I'm not going to be viewing at the predictions, but you can make some sort of a UI where you can load in an image, then the neural network gets triggered and it works. Currently, I'm not going to be doing that because I'm not much of a UI kind of guy. I usually just implement this kind of things. Since the data we are loading in is a little bit larger and we are using like this type of a technique, it will take some time for the epochs to run, but you can see it's alright. So 70% accuracy, obviously that's not what you want. You want to probably have a bigger accuracy, a better accuracy. 73.1. So I'm not going to be going with some crazy accuracy for this one. You can see that like you can then just add a convolution layer, but I feel like it won't work right now because I have not reshaped the data. So let's just try it out, but I'm sure it just won't work because we haven't really given it any reshaping things and all of those parameters, so it won't work. But just for the sake of it, I'm just gonna be showing it to you guys. But before that, we need to also do one more step. So actually, I'm just gonna give it as a challenge to you guys to try and make it as a convolutionary approach. So this is a very useful neural network that I've just made over here. It's like you can actually deploy it to the real world. It can actually help out people. Now the challenge I can give it to you guys is get yourself a high accuracy on this model and then make a UI. So I will provide you some code if you want. Comment down below if you want some more code about this. I've actually written some code that can use some pixels and stuff. If you are using Pygame for this, make sure make it so that you can load in any sort of city scan of the lungs, and based upon that, then you trigger the neural network, and then the neural network will have a prediction whether you are COVID positive or not COVID positive. So this is a very awesome neural network, and I hope you really enjoyed this video. Uh, if you want to see more of these videos, please comment down below. But this is just that very simple neural network. You can also just evaluate on the testing data. But I figured out that I don't really need to do that. It's alright. So yeah, and you know what? I'll just help you out a bit with the convolutionary approach. So let me actually open up a little Google Colab and I will just show you how you can easily do that. I feel like it will take some time. Let me open up a new one only. Google Colab. You can also perform this on any of the TensorFlow dataset. Just download it and then you can use it. So yeah. So let me actually look SVHN crop. This is the cancer neural network, consistency, and then I'm gonna open the real world example. Let me quickly just show you the code that will be required to do this. So all you will need to do is literally, let me actually quickly show you guys. Yeah, just this code. You need to just quickly reshape it, and you'll be able to come up with it. Let me actually show it to you guys. It won't work. I'm not sure if it will work or not, but I'm just trying and seeing. Just do that. Actually, we don't need to do it over here. We need to do it over here. So all you will need to do is just go train images to train dataset. train images to train data set, and then instead of passing this, you will need to pass 3480 comma 4248 comma 3 comma 1. This is the thing you need to pass. One last thing what you will need to do is I'm just gonna get rid of these layers. Control X. We probably will need to paste them, so that's why I'm just gonna add a keras.layers.conv 2D 64 filters, 64 column size, 3 filters, activation of value, and a input shape of 34804248 and let's start one. And another convolution here, conv 2D. Oh my god, why am I doing that? 2D. I forgot to type out layers. Keras dot layers dot. This should work. 32 by 3 activation is equals to value. There we go. So just do that, and I think this will make a convolutional layer. Yeah, pretty cool, right? Let's see. Let me have a look. Alright, what happened? The reshape. Alright. Release it. Oh, okay. I think instead of this, I will just need to do it image. As I told you, I have not planned this, so there's no, like, I can't guarantee if this will work or not. So let's see. Alright, so image data generator does not have anything called reshape. Alright, this is not work. So as I told you, I don't know if this will work or not. Obviously right now it won't work because it's not 4-dimensional data, but you know, you can like use it, and right now it's exceeding my memory, so that's kind of bad. I will need to stop the code running real quick or my computer will lag. Oh my god, that's bad. Alright, I hope it does not lag. Alright, I need to stop the code running. I need to stop the code from running. My computer really lags if my memory usage gets a bit more. So that's why I'm not sure if I'll be able to show this to you guys. I think I'm not gonna go for convolution rules right now. I'm just gonna undo all of that. There we go. So there we go. That's your neural network. I hope you enjoyed it. This is very important and very awesome. So that's it for today, guys. I hope you enjoyed this video. If you did, like and subscribe to the channel. Comment down below if you want to see more real life data neural networking. And until the next time we meet, bye bye.